today we're going to look at a couple more formulas that can be given to you that you have to use logs or exponent laws to solve them. One of them is right here, and this has shown up on the final exam a couple of times. The future value of an investment. And R is the amount of regular investment. So this is where you decide, I'm going to start putting away $50 a month. Starting now so that when I'm 20, I can have a trip somewhere. See how much money I would have at that. Well, you put $50 a month away, it's getting interest, which is compound interest, over a certain period of time. But because you keep adding to it, it keeps growing that way, plus the interest keeps growing on that. So this formula figures out how much it's going to equal in the end. Now, R is the amount of the regular investment. I, in this formula, is the interest rate per compounding period. So I is equal to the interest rate per compounding period, and N is the number. Well, I guess that's not N. It's a little bit complicated, this formula, because it's the interest rate per compounding period. So if you have an interest rate of 7% compounded monthly, then you would have 0.07 divided by 12 for I. And so it's a little bit more complicated than the regular formula. In the regular formula, I was just the interest rate. Now it's the interest rate per compounding period. So we look at our first example that's going to use this formula. I'm going to go back and steal that formula. I'll just write it out. So the formula again was future value equals R 1 plus I to the N minus 1 in a set of square brackets divided by I. So determine how many monthly investments, so we're going to be solving for N, of $200 would be made into an account that pays 6% interest compounded monthly for the future value to be $100,000. So we plug in everything that we know into the formula. $100,000 for the future value. We're plugging in 200, 1 plus, and the interest rate per compounding period in this case would be 0.06 divided by 12 n minus 1 over 0.06 divided by 12. N is in the exponent. We're going to need to solve for N using logarithms, but before we do that, just like before, let's simplify this equation so we get the power by itself. Right now, I'm dividing by 0.06 divided by 12. I'm going to then multiply both sides of my equations to get rid of that fraction. If I do that on my calculator, 100,000 times 0.06 divided by 12, I get 500 on this side. We have to be careful that we include all of the brackets every single time that we write it, so we don't mix things up as far as order of operations go. Why can't I add 1 to both sides right now? Because there's that $200 in front, or the 200 value in front. How could I get rid of that 200? Divide both sides by 200. So that's going to give me 5 over 2 on this side. And so I have 5 over 2 equals 1 plus 0.06 divided by 12. And at this point, now those, like, can you see that these extra square brackets that were around here were no longer necessary now? Yes? You could write 2.5 if you wanted to. Personal thing, although if you don't have a calculator, then fractions will be easier to do the mathematics with. Okay? But if you add 1 to both sides, then you're going to get 3.5, if you wanted to do the decimal, equals 1 plus 0.06 divided by 12. And we finally did all of that little algebra just to get our power by itself. We now can take the log of both sides, or the natural log, and that n can come out in front. To get n by itself, we can divide, take out our calculator. Type it in, log of 3.5 divided by log of 1 plus 0.06 divided by 12. 251.178. Now the question asked, how many investments would we have to do to get $100,000? You can't make a partial investment. You would need to make 252 investments of $200. So let's just think about this number a little bit, okay? 252 investments. I'm going to take out my calculator because 252 divided by 12 would tell us how long it's going to take. 21 years. Okay, so if you're really planning an amazing trip to Europe that you're going to spend 100 grand on this trip, okay, it's going to take 21 years if you start putting away $200 a month right now. That would be probably a pretty, I think for 100 grand you could probably have a pretty good trip, maybe. Now, the other thing though I want you to look at is if you did $200 252 times, how much money did you actually put in? Only $50,000. How much was it worth in the end? $100,000. This is the power of compound interest. If you can save some money, it will grow for you. And so one of the things that you can do during your lifetime is start figuring out where can I get some interest rates and how much money could I afford to put away. And then later on, when you want to pull it out, it will be a lot more than you actually put in. In this case, it's doubled. By putting in $200 a month for 20 years, you're basically doubling your money when you take it out. Pretty cool. All right, questions for this one, but we're not going to go to them. I'll give you the questions at the end. I want to show you a program on your graphing calculator if you have one. So you can write this down at the top column of page 431. There's a program in your calculator called TVM Solver. And there's programs very similar to this that you can search on the internet and find. To find TVM Solver, you go to your calculator, you go to Apps, the very first one is Finance, push Enter. The very first one again is TVM Solver. So Apps, and then Finance, and then TVM Solver. So if you have your calculator here, go to this screen. On this screen, you will have the following. NIPV, okay. So first of all, we're going to describe what each of these things stands for, and then you're going to see how you can use this to figure out a bunch of these questions that we're going to be doing today. Plus, you can figure out how to solve a bunch of questions that you might have. This is probably the most important program that you have on your calculator when you're thinking about buying a car or buying a house and finding out how much it's going to cost you and seeing the differences in the interest rates. And understanding this, I talked before about saving a lot of money over the course of your life with interest rates. This program can help you see how that works. N stands for the number of payments. I is the interest rate, not as a decimal, just a regular number. PV stands for present value. PMT stands for payment. FV stands for future value. Payments per year and compounds per year. So number of payments, interest rate, not as a decimal, present value, your payment, future value, payments per year, and compounds per year. And because this program can be used to figure out if you're having a loan or if you're getting money, it needs to differentiate when you're getting money and when you're putting money away. Okay? So, as a special note, anytime you are putting money away, that means you're either taking it out of your pocket and putting it into the bank, taking it out of your pocket and paying the bank. Anytime you're taking it out of your pocket and putting it away somewhere else, that number has to be negative. Anytime you take money out or get money, that number has to be put in as positive. So we're going to look at the example that we just did and see how we could get our calculator to solve for that 251 a lot quicker. So we go to our calculator. I'm just going to leave the number in n because this is what we're wanting to solve for. We want to solve for, I'll just put a 1 in there for now, just so that there's a number. We want to find out how many payments. We were told the interest rate was 6%. At present, we have zero money in our bank account, but we're going to be putting away $200 a month. The future value, when we take it out, we want it to be $100,000. So that number will be positive because it's coming back to you at the end. You're making 12 payments per year, and it's compounded 12 times per year. So once we've got all of the information in there, we can go up to the n, and above your enter button, it says solve. So you can go alpha and solve, and we get 251.178, the exact same number that we did all that math for, comes out immediately. And like I said, there's TVM stands for time value money, and it's a common acronym for this kind of calculator that can figure this out for you. And so one of the things that's really neat about this is you can fiddle with one number and see how much of a difference it makes. So one person gets 6%. Another person doesn't do their research. They only find 4%. How much longer does it take them? Well, 252 payments versus, we just have to go alpha solve, 294. That's an extra 42 payments times 200. 4% costs you $8,400 more to get the same thing. Plus, if we go up another 42 payments, that's another 3.5 years that it takes longer to get to that same amount. So we can see how powerful an interest rate is. Okay? You know what interest rates are right now, if you're lucky? Like, if you're lucky, you might get 2%. So now, oops, second alpha solve. 363 payments it's going to take you. So we can fiddle with numbers in here and figure out things quickly. Right? How much would it cost you to go to Europe? Right? How much do you want to have saved to go on a trip to Europe? Maybe you want to save up. What do you think? Tickets, everything, $4,000? You start putting away $200 a month now at 2%, 19 months. You're ready to go. Could you put away $200 a month? Are you making enough that you could do that? You don't want to. Your lifestyle, you need to make sure that you get your coffee every morning and have to, all those kind of things. So, but it gives you a way to plan or to figure out how could I save money if I wanted to do something. Okay, so questions for question 1, and we're going to do question 2 right away, are 3 and 6.